Good afternoon. Today I'll be talking about underpinning. uh, First, we need to introduce the concept why to use underpinning and what is underpinning from the first place. So, underpinning is simply the process of strengthening and stabilizing the foundation of an existing structure or any other structure or a neighboring structure. So, we will need it maybe if we have one of these five cases. So if the original foundation system is not strong or stable enough, or if the usage of the structure has changed, so that for sure will change the loads that we have. If the properties of the soil supporting foundation may have changed, whether due to swelling or having organic matter or whatever, or change maybe in the water table, groundwater table, or maybe the construction of nearby structures necessitates the excavation of soil supporting existing foundations. And the fifth case, if it is more economical to do that rather than uh, uh, reconstructing the structure from the first place. So we have 7 different methods of underpinning that we'll be discussing today. To make a long story short, the first five, they are actually local methods concerned with localized problems within specific um, footings or pile caps. However, the last two, number 6 and number 7, they are mainly used if the general foundation system, a group of footings or a group of pile caps um are facing a certain problem. So we will be using this number 6 and number 7 to encapsulate the whole foundation system. So the first method is the temporary support with maintenance jacking. So this method is mainly used if we have a local failure within the piles, whether, by the way, the piles could be timbered, could be steel, could be concrete. So we use this method if the failure is in within the first few meters of the uppermost few meters of the pile. So in such a case, we will be simply demolishing these piles, of course, with a specific sequence. But of course, before doing that, you need to shore the structure. You need to shore the footing first in order to have a temporary support for it. Then you'll demolish the existing defected portion and place steel members instead of the defected portion, typically I-beams, and simply you will after placing these steel sections, you will concrete the whole section, the whole volume. So it's as if you are having a deeper pile cap. This is basically the idea. However, if you are having a situation along the depth of the pile, so if you are having a deterioration along the depth of the pile itself, you can't do that. This thing is useless because you could not remove the whole section of the pile. In such a case, maybe the coming option will be more viable. So bracket pile underpinning is used mainly if the previous option is not valid. If the jacket, they are not valid. Because in such a case, now I will have a new pile, a new bracket pile. This bracket pile, I will transfer the load to this new pile instead of having to depend on a deteriorated situation that nobody knows. I mean, only God knows where to which extent are these piles deteriorated, and for how long deep they are deteriorated. It's not that easy to know something like that. So if you're uncertain, so this would be a much better option, is to have a neighboring pile and connect it using a bracket. this bracket is typically cut from a wide flange section. Okay, and of course the connection between the bracket and the pile, this is a little bit critical because it is suffering from high shear and high moment together. This is considered as a short cantilever, and this pile should be designed to carry an eccentric load, so it will be carrying axial forces and bending moments together. So it will be a little bit problematic in terms of design. Another option is to have a slant augered underpinning uh, technique. So instead now of having a steel pile, no, I'll have a slanted auger pile. So this is a reinforced concrete pile at an angle. So uh, now the load will be directly transferred to it. However, again, we have here a very big issue when designing this thing, because again this if you look, the load is coming at an angle to the plane of the pile, so actually it will cause axial forces, it will cause bending moments, and it will cause shear forces in this pile. So this pile should be checked for all of that. um, the fourth option we have is what we call pit or pier underpinning. So in such a case, you are removing everything and you are simply pouring concrete. This is very simple. So now I'm removing everything and I'm pouring concrete. But again, that means that you should have a soil that has an acceptable bearing capacity at a nearby location, which is not always guaranteed. So if the bearing layer, bearing strata is deep, you could not use that option. It's invaluable. Um, the fifth option is micropile underpinning. So micropile underpinning, it's simply very similar to what we did before, using the neighboring steel pile and having a bracket. Now instead of having a steel section, I'll get a micropile. So this micropile is simply, it is a steel casing, a steel pipe. This steel pipe, it has some pre-tensioned cables in them. So you pre-tension the cable and then you grout. So now it has a very high capacity. However, the cross section is not that big. So that will make its construction a little bit easier. However, its cost will be much higher for sure. Then comes the option number 6, which is the slurry trench wall underpinning. And this is much valid if you are having a group of piles that failed, or a group of footings that failed, or maybe one side of the structure has suffered significant loss of bearing capacity under it, or suffered maybe significant swell or differential settlements. So in such a case, you will need to increase the bearing capacity of the soil itself by encapsulating it by the shear walls, by the diaphragm walls. So these diaphragm walls will increase the whole capacity of the whole thing, because it will confine the soil beneath your structure. So now the foundation system as a whole became stronger. It's not a localized thing by localizing a localized effect at one footing. No, now you are increasing the whole foundation system, increasing the bearing capacity for the whole foundation system. Then the last option is grouting. So grouting, it could be, by the way, you have different types of grouting. You could have cementitious grouts, you could have chemical grouts, you could have it by different mechanisms, single rod, double rod, triple rod, whatever. But the concept is the same, is that you are grouting the soil beneath the structure in order to increase its compressive strength, increase its stiffness, increase its bearing capacity. So now you will not need the piles anymore. You don't need anything anymore. The soil itself became more like a cementitious material. So now the soil itself, it became cemented to each other. So now you will be able to carry whatever loads that you need to carry. Of course, we have associated structure systems. Some are temporary, some are permanent. So if while working you need to transfer the load somewhere, so this is one option, is to have this beam. This it could be timber, it could be steel beam. Another option, this is a permanent option, is to have a cantilevered needle beam. You could see this is a cantilever that will transfer the load to two piles. One will be in tension, the other in compression. This is a different beam. It is more like a simply supported structure now. So again, this is concrete. So this is another option other than everything else that we have talked about.